Alright, so today we're going to talk about graphing and inverse functions of trig functions, or 6 trig functions. So some of the study skills we're going to need for this chapter: you got to be focused, you can't be distracted, we can't have a lot of talking in class. You're gonna probably struggle with some of this material, but it's nothing you can't do. We need to focus on being resilient, focus on, really going after the problems and working hard in class and outside of class. So you have to be intended to succeed. You can't just go through the motions and not study outside of class and not focus in class, a lot of talking. So this can't be like the last chapters that you might have done really well with. So if we're going to end up graphing our trig functions, we can always do this in our calculator. So we can just put y is equal to sine of x in our calculator. Let's find. So if we put this in our calculator, then we end up saying that we have kind of a wavy function, wavy line kind of thing, nothing like you've ever graphed before. So what do we notice about sine? We can notice that it's kind of got a wave to it. Pen's falling apart. So if we have a wave, we know it repeats, and we also know that if we look at the range, so if we're looking at the values of y on this axis, then we know it's between 1 and -1. So we know our range is between -1 and 1. So just if we're looking at a sine graph, we can always do an XY chart just like we have in the past whenever we're graphing functions in our Algebra 2. So what's our sine of x is going to be, sine of 0 is going to be 0. Sine of pi over 4 is going to be square root of 2 over 2. Sine of pi over 2 is going to be 1. Sine of 3 pi over 4 is going to be our square root of 2 over 2 again. And then sine of pi is 0. And then as we can see here, it starts to repeat again, so we have our square root of 2 over 2. And then, but see, the thing is about our 5 pi over 4 is, since we're in our next quadrant, as we start to go down 5 pi over 2, if you put that in your calculator, we're end up going to get negative square root of 2 over 2. And we'll notice that this is the same trend for all of these. So since we're doing that for all of these, we can always end up following the same things as we did over here and then apply that to our next three. So we have negative square root of 2 over 2, we have -1, negative square root of 2 over 2 again, and then 0. So if we look at our graph down here, we can start to graph these points. So square root of 2 over 2 is going to be a little bit more than 1/2. So we can go about right there. And then at pi over 2, we have 1. So I'm getting a little crossed up here. So if we go back, we start at 0. So we plug 0 in, we have 0. We go up to at pi over 4, we have a little bit more than 1. And at pi over 2, we have 1. Come back down to 3 pi over 4. It's going to be the same value as before. And then at pi, we have 0. So if we get to pi over 4, we come down, but we have our negative. So we go all the way down here, a little bit more than half. And then we have our -1 at 3 pi over 2. At 7 pi over 4, we have our half. And then at 2 pi, we're back to 0. So if we connect those, we can see that we get that wavy function. And if we start back at 2 pi, we can kind of see that we're starting to maybe do the wave again. So let's kind of expand on that idea. So if we do our cosine, we plug that into our calculator, we can see that if we plug our y is equal to cosine of x, we see we get that wavy function again. So what's the difference between this graph and the last graph? Well, we still have our wave, but it looks a little different. So where have we shifted? We've shifted at our range. We don't start at 0 as we did before in our graph and with sine. So what's cosine of 0? It's going to be our 1. So we're going to be starting at -1. So our range is still going to be between -1 and 1, as we can see on our graph. So if we go to graph our function of cosine, we can tell that just like with sine of x, we start at 0, and then we come over and we start to repeat at 2 pi. So if we do cosine, we start at 1, and then we kind of follow the same trend, but it's as if we shifted over our 0 to pi. So we've shifted our pi over 2 to here to our y-axis, and we start to repeat. So if we're talking about amplitude, what we're talking about is the range. How far up and how far down does it go? So if we look at this, we want to talk about the absolute value, so the distance from the x-axis. So if we're talking about from our x-axis up or our x-axis down. So for sine, our amplitude is going to be 1. If we talk about our period, we want to talk about where we're repeating the function. So whenever we're repeating the function is if we come out to here on sine and we start over again and we continue out, it'll start to repeat after 2 pi. Just like if we think about the unit circle, we can start at 0, come back around. Whenever we reach 2 pi, we're back to 0, and then we start back over. Same thing for cosine. We start at 1. Our distance from the x-axis all the way up and all the way down is going to be 1 from each one. So our amplitude is going to end up being 1. So our period, when we start to repeat again, just like with our sine, it's going to end up being 2 pi, because just like with the unit circle, once we start at 0, we rotate all the way around, we get back to 2 pi, then we start to repeat. So if we sketch extending the graphs of sine and cosine to 4 pi, just kind of emphasizing on that repeat. So if we start at our 0, and then we go to pi over 2, and we go to pi, and then that'll be good. So after pi, we have 3 pi over 2. Just kind of shorten up our graph so we don't have to write out every single one of these. 5 pi over 2. We keep adding a half. It's 3 pi, 7 pi over 2. And 4 pi. So if we start to graph this, we know we have, this is going to be our 1. Here's our -1, because we know that's our amplitude, how far up it's going to go, how far down it's going to go. So we start here, and we know at pi over 2, it's going to be 1. At pi, it's going to be 0. At 3 pi over 2, it's going to be -1. And then at pi, or 2 pi, we know we're starting to repeat again, so we get back to 0. So we can repeat the same thing. So we could even plug these values into our calculators in radian mode and still get these values out. So at 5 pi over 2, we're going to have 1. At 3 pi, we'll have 0. At 7 pi over 2, we'll have -1. And at 4 pi, we're back to 0. So if we connect these points, we can kind of get that idea of the wavy function that repeats. So as we can tell, where we can kind of get that idea of period, because right here, as we can tell right here, is where we start to repeat again, because we have our wave and then we repeat the same function, it's almost like a mirror image, like we're shifting it over. So if we do the same thing for cosine, where do we start on our, we have to establish our 1 and -1. Whoops. So our 1 and -1, because that's going to be our range up and down on the y-axis, how far we're extending. And we know at 0, we start at 1. So let's go ahead and label our axes. So if we label our axes pi over 2, and then we have pi, and then we have 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and then we have 7 pi over 2, and then our 2 pi, where we start to repeat again, or I'm sorry, our 4 pi. So if we start at 1, at pi over 2 we're going to have 0, at pi we're going to have negative 1, at 3 pi over 2 we're going to be back to 0, and at pi over 2 we're going to start to get back to 1. Just as we did over here, we started at 1 and we end at 1 whenever we get back to our 2 pi. So if we go to 5 pi over 2, we're back to 0. At 3 pi, we're down to negative 1. 7 pi over 2, back to 0. 4 pi, back to 1. So if we connect these, and we get that idea of the wave function, but just like with our sine, it's almost shifted over. So we start at 1 and we still start to repeat after our pi over 2, our 2 pi. So since we start to repeat at 2 pi, we can see that this is 2 periods of our function of cosine. So if we use in our graphs from sine of x of 1/2, using our graphs from 4 and 5, what we just did, let's find all the values of x on 0 between, or with x between 0 and 4 pi, for which is true. So what we want to find here is, just like before, we want to find out where, if I gave you on the last quiz from last section, where we had to find 2 triangles in our unit circle, whenever we're finding that, we're going to talk about how we use our reference angles, and then we use our special triangles to end up finding the exact values. So in order to find a theta, or an x in this case, we end up having to take the inverse of both sides. So we end up having sine inverse of 1/2. So this ends up giving us our angles, which are going to be equal to 30 degrees and 150 degrees. Okay, so we know that if we draw a triangle, we end up rotating around. From our home base, we end up rotating around to 135, or I'm sorry, rotating around to 150 degrees. Our reference angle in here is going to be 30 degrees. And then if we end up rotating 30 degrees, this angle is going to end up being our 30 degrees. So what we end up finding is where sine is positive, and we know with our all students take calculus, we can end up finding out where sine is positive, and that's where we're going to end up using our reference angles. So if we end up looking at this, we know that for these values over here, this is going to be pi over 6. And if we look into the second quadrant, we're going to end up getting 5 pi over 6. So since we have 5 pi over 6, how are we going to end up getting for 4 pi? Because that right there is one rotation all the way around to 2 pi. So how are we going to end up finding that 4 pi? Because we have to find out, because it repeats, right? So just like in our graph, when it starts to repeat again, we can go after the same values. So all we have to do is add 2 pi to our 2 values we had before. So if we add 2 pi to them, we end up getting 13 pi over 6 and 17 pi over 6. Okay, so same thing for cosine of x. So we're going to end up drawing our triangle, or drawing our axis. We end up using our, so we find inverse cosine. So x is equal to our inverse cosine of square root of 2 over 2. So we end up rotating around 100, which we know is 135, or is 45 degrees, or 135 degrees. So we have our 135 degrees, which is going to give us a 45 degree angle here as our reference angle. And then we end up rotating all the way back around, and we rotate even further into our next and third quadrant because we want to know where cosine is negative. So we end up having our 45-degree angle over here also. So since we have that, what do we end up finding with these values? We end up getting our top one is going to be 3 pi over 4 and 5 pi over 4. So if we end up adding our 2 pi, we end up getting 11 pi over 4 and 13 pi over 4. So if we go down here to cosecant, what is cosecant? So we know that cosecant is the reciprocal of sine. So if we go 1 over sine, if we just rewrite it in sines, then we have 1 over sine of x is equal to 1. Now, if we end up finding that cosecant 1 over sine of x is equal to 1, then we know that sine of x has to be 1 because 1 is 1 over 1 also, so we can say that 1 over sine of x is equal to that. So if we end up finding that, then where is sine equal to 1? We know it's pi over 2 and 5 pi over 2. So if we end up moving on to our other trig functions, talking about our graphs of tangent and cotangent, the tangent and cotangent functions are like secant and cosecant. So they're going to end up, we can end up writing it in sines and cosines on our calculator and using our zoom trig and end up just like we did before to give us an idea of what it's going to look like. So what's the period of that going to be? Whoa. Is this supposed to be here? So, okay, so if we end up plugging this into our calculator, we get this crazy wave function. And we're starting to wonder why in the world it starts to look like this. Why doesn't it repeat? It doesn't have that. It has sort of a wave look to it, but it doesn't necessarily repeat like we did with the last one. It's not always connected. So why is that? Well, if we end up looking at cosine, well, if tangent of x is equal to sine of x over cosine of x, and we know that cosine is 0 at pi over 2, then we end up, if we plug pi over 2 in for both of these, we end up finding that this is 1 and this is 0. But this cannot happen. This is undefined. So we end up finding that there's asymptotes at certain values. Okay, so since we have these asymptotes, with these asymptotes, we cannot, at those values, define them, so we end up, the graph ends up going off to infinity or negative infinity. So if we end up trying to graph each of the following and give the period and the vertical stretch, then why do you have 1/2 tangent of x? Okay, so if we talk, okay, so, jeez, alright, anyways, so we're talking about tangent of x, so if we want to plug in, just like as we did before that, we can set up our xy chart, if that helps you think of this any better. So if we end up plugging in at, if we think about at 0, can we have a value at 0? Because if we plug in, if we set this equal to sine of x over cosine of x, do we have a value at 0? Yes, we do, because sine of x will end up equaling 0, and then we have to think about cosine is equal to 1. So we'll have 0 over 1. Is that okay? That's alright, because 0 isn't in our denominator. So we end up getting 1. So our point is going to be 0, 1, so we end up coming up here to 1. Alright. Goes through the x-axis, so. Oh, no, that's right, isn't it? 0 over 1 is off. So we end up simplifying this and we get 0, so we end up getting 0 and 0. So our actual point is going to be 0, 0. So if we have to think about this every time we start working with tangent. We have to think about what we're plugging in for sine, what we have on the bottom, what we have on the top, because we cannot have 0. So we have to think about where cosine is going to be 0 whenever we're dealing with tangent. So if we're dealing with that, then we have to think about, okay, at pi over 2 we have a cosine is going to be 0. So at pi over 2 we have to have an asymptote. So where else are we going to? We're going to have repeating, just like with the last functions. We're going to end up having a repeating of the asymptotes, just like we did with our period, right? So if we think about every time that cosine ends up hitting 0, we can put an asymptote there. So if we have pi over 2 here, we know that negative pi over 2 is also going to have an asymptote. So if we have an asymptote negative pi over 2 and pi over 2, we can just end up repeating that. So at 3 pi over 2, we know we're also going to have another asymptote. This repeats on the other side at negative 3 pi over 2. And then if we end up extending this out, because we want to find out at 2 pi where we're at negative 2 pi, and then over here at 2 pi where we're repeating. So if we start here, we end up saying that we can never reach our negative pi over 2, and we can never reach our pi over 2. So just as before, we're going to end up going through our origin and never quite reaching our asymptotes. And just like before also, with the repeating, we have that period. As our asymptotes repeated, so does our graph. So since our graph repeats, we can end up repeating this in each one of our kind of sections that we have between these two. So since we're repeating the graphs, we have to know where this is crossing the x-axis. So we want to know where sine of x is going to be 0. Well, where's sine always 0? It's at pi and 2 pi, or 0. So we have our 0 already. We've plugged in. This right here is going to be our negative pi, and this right here is going to be our positive pi. So we're going to go through that point, and then we're going to end up repeating over here, but we'll just stop there so we don't go too far. And we'll end up over here also doing the same thing where we kind of come off the graph and it repeats on the other side. So if we do cotangent, we all know that that's going to be the inverse of tangent, so we can write cosine of x over sine of x. So with our cosine of x over sine of x, we're going to do the exact opposite. So instead of thinking where's cosine equal to 0, we're going to be thinking of where is sine equal to 0, because if we know where sine is equal to 0, those are going to be our asymptotes. We can go ahead and set that up and get that done with. So if we try to think of where cosine is 0, we know if we think about the graph of cosine, we start at 1, we come down, and then we start to repeat. We come down to negative 1 and start to repeat. So we want to know these values, where it crosses on those. So if we're looking at that, actually let's go back. So we're actually going to be looking at where sine is equal to 0, not cosine. So sine starts at 0. We're going to just extend out to our period. Whoops. Seems like I've mirrored the image. So we want to end up finding these values where it crosses the x-axis, because that's going to be where our graph is equal to 0. So where is sine 0? We know that sine is 0 at 0. So we know that this, our origin, is going to end up being one of our asymptotes. We know that our negative pi, or actually, if we think about our unit circle, we know at pi, we know we're going to have an asymptote because that's where sine of x is also going to be equal to 0. We know repeat at 2 pi. And we know that we can mirror this on the other side. So we can have negative pi and 2 pi. So anyways, if we think about, if we graph this, how do we know which way it's going? Does it look just like our function over here? Will we have the exact same graphs but just shifted over? Well, we can't say that for sure because of the fact that this is going, our cotangent is going to be the inverse of our function. So they're not going to look exactly the same. So since they're not going to look exactly the same, we have to think about whenever we do an inverse, we're switching the graphs. So we end up putting in values and getting excuse me, getting in different y coordinates whenever we put in the same x values as we did for tangent. So if we set up our xy chart, we know 0 isn't going to work because it's going to be undefined. So we can just put an x there. So what's our next value going to be? Well, we know we can't plug in pi over 2, but we can't plug in pi, but we can plug in pi over 2. So if we plug in pi over 2 for cosine, we end up getting 0. So we end up getting 0 over 1. And sine will be 1. So we end up getting 0. So that's where we're going to end up crossing. And we know that in the middle of these, just like in tangent. See, the beautiful thing about these is, if you can figure out one of the graphs inside of your asymptotes, you pretty much repeat the same graph over and over and over and over again. So we can end up, as long as we can find one, we can end up just basically repeating tangent and cotangent in the rest of the graphs, no matter whether we multiply it by something or anything. So, anyways, so if we start to go through this, what is our, so we know we're going through our points here. So as we get closer, if we think about pi over 4, so our cosine of pi over 4 is going to end up, if we go back and look at our xy chart, our sine of pi over 4 is going to be square root of 2 over 2. I'm going to switch colors so it kind of stands out a little bit more. So if we go, our cosine of pi over 4 and our sine of pi over 4, what's that going to give us? Well, our sine we know is going to be square root of 2 over 2, and our cosine is going to end up being, get lost in my own notes here, our cosine of square root of 2 over 2 is going to be our 3 pi over 4. Is going to be our negative. So actually, our cosine of pi over 4 is going to be where cosine ends up being positive, so it's going to be square root of 2 over 2. Okay. So we end up having the same thing because we're going to end up dealing with a 45, 45, 90 degree triangle. So we end up having 1, 1 square root of 2, so it's going to end up being the same value. So since we have square root of 2 over 2, we can end up multiplying by the reciprocal, which will end up giving us, if we multiply something by itself, we end up getting one of them squared, which will end up giving us 2 over 4, which gives us 1/2. So if we get 1/2, whenever we plug in our pi over 4, our pi over 4 is going to be here, so we know our 1/2 is going to be about right in there. So if we think about, if we're rising on this side, we're falling on this side, because we're dealing with the inverse function of tangent, just like we did over here. So if we want to, instead of having to start plugging in our 3 pi over 4, our 5 pi over 4, and dealing with all these different numbers, we can actually end up just mirroring the graph. I'm not sure if really mirroring is a word, but sounds good to me. So if we end up dealing with that, if we end up using that, we can end up just using the fact that it repeats, and then we end up with the same graph. So since it repeats, our graph, as we can see, it kind of goes it does exactly the opposite. So it ends up rising on the left and falling on the right. for our cotangent and end up rising on the right and falling to the left on our tangent. Did I say that right or backwards? Okay, so if we give the period, so just as we did before, our period for sine and cosine was 2 pi. So that's where we end up repeating. Well, here, where do we start to repeat? So we come down, and it's where we reach our asymptote. So our period is going to end up being a little different. So do we end up having a period? Because do we repeat the graphs? Do the graphs connect? So if they don't really connect, is this... I just want to make sure, because I was kind of looking over this in the book. Does this... There is a period. Okay, so the period is pi. Okay. So the period we always have is pi because of the fact that here we start to repeat. We start at 0, we go down here, and then we have to jump back up here, and then we end up repeating at pi. So as we can tell, every time we start over, we have to start over. That's where our period is. So just like over here for tangent, if we're looking here, where do we end up repeating? We go from negative pi over 2 to pi over 2. So if we go from there, from negative pi over 2 to pi over 2, is our period 0? Because if we just subtract the 2? No, because our distance can't be 0. So what is our distance between these two? That's what we're finding. That's what we're talking about whenever we're talking about period, is the distance between where it starts and where it starts to repeat, where it starts over. So that's going to be our period, is also pi here. So if we're extending the graph of cosine, if we sketch the graph of each for all the way from negative 4 pi to 4 pi, we're going to end up just as we did before. So we'll say this is our 1, and this is our negative 1. Where's at 0, at our 0, what is cosine? We end up having 1. So we can end up listing these out just so we can go ahead and get this done. So we have our pi over 2, our pi, our 3 pi over 2, our 2 pi, 5 pi over 2, our, was it 4 pi? Nope, 3 pi. Get myself confused here. So we end up having 3 pi, and then we have 7 pi over 2, and then we have our 4 pi. So just like on the other side, we can just repeat the same numbers. Hopefully your graph looks a little bit better than mine, because my numbers aren't quite spaced out as nicely. So our negative 3 pi over 2, our negative 2 pi, negative 5 pi over 2, negative 3 pi, negative 7 pi over 2, and negative 4 pi. So we start at 1, because that's what cosine is at 0. And then what is cosine at pi over 2? We know that's 0. What's cosine at pi? If we plug that in our calculator, or we even look at the unit circle, we know that our cosine of pi is going to end up being negative 1. And then we start to repeat. But we're not doing our period. So if we start at 3 pi over 2, we know we end up getting back to 0. And then at 2 pi, we end up getting back to 1. So if we think about this, at 2 pi, what's our period for cosine? We know that it's going to be at 2 pi, it starts to repeat. That's our period for every single one of these. Well, or for our cosine and sine. So since we can use that fact. That's really helpful. So since we have a period, what do we say? It starts over. The graph starts over. So we can just repeat this function, this graph, as we go. So we can just, at 5 pi over 2, it's going to be 0. At 3 pi, it's going to be negative 1. Back to 0. Back to 1. So we end up repeating. Now is it going to change for our negatives? Is anything going to change? So just as we looked before, whenever we did it on our graphing calculators, we end up looking at it and we can say that it just repeats. It's a wave function and it repeats. We have our period. So we can just follow the same exact pattern. So we end up going down to -1 at our pi's, and then up to 1 at our every two as we repeat. So our period is still 2 pi. So we still have to make sure at -2 pi and -4 pi. So every time we get back to 2 pi, we're going to end up repeating our graph every single time. So that's the advantage of having our period. So once we graph it once, we can just end up repeating it after we get to 2 pi. So if we're sketching the reciprocal, so we're talking about secant of x. So we know sine of x. We've seen that. So how is sine of x related to secant of x? Actually, I've got mine crossed up. So we're actually talking about cosine of x. So cosine of x is the reciprocal of secant of x. So since it's the reciprocal, it'll be 1 over secant, 1 over cosine of x is equal to our y. So since we're doing the reciprocal, if we think about graphing cosine just like we've done before in the last few slides, so we end up going up to 1, we go down to -1, we start at 1, at pi over 2, at pi, 3 pi over 2, and at 2 pi. So if we end up sketching this graph just as we did before, we have 0, -1 at pi, back to 0, back to 1, because that's where our period ends. So that's what our graph is going to look like for cosine. Now if we're talking about the reciprocal, which we have here, we're talking about a whole set of different values. So at 0, right here on the y, whenever we're plugging in 0 for this, and we get 1, we get 1 over 1. So let's just do an xy chart. So we plug in 1 for our cosine of x. So we end up getting 1 on the bottom, and then 1 on the top, so we end up getting 1. What happens when we plug in, when we end up plugging in pi over 2? So cosine of pi over 2 is 0. Can we have 1 over 0? We can't have that. It's undefined. So since we have it undefined, just as we did with the tangent and the cotangent, we end up talking about if it's undefined, automatically you can put asymptotes at every one of those. So we have, so that's our first one. Now the thing that I love about period and using our period to our advantage, the repeating, is that we know that if we have it here, where else are we going to have it? Well, every time that cosine hits that 0, we know that we're going to end up having another asymptote because of the fact that whenever we plug 0 in, we're going to have another undefined. So it's going to be 1 over 0 again. It's going to be equal to our y. So we end up having, if we have it undefined, then we can put asymptotes at those points. So since we have our asymptotes, what if we continue this graph over here? So if we continue this graph, what would happen at negative? If we plug in negative pi over 2, we end up having, for cosine, we end up having our 0, and then we go down to -1 at pi. So if we continue to look at this, then can we just repeat and flip this over and use the same things? Of course, because of the fact that we can use it to advantage our period. I think, nope, it didn't cut me off. I thought it did. Because at those points, we can't end up having a 1 over 0. So since we can't end up having that, we can use our inverse, because this, our cosine, if we use our inverse 1 over cosine, just like as we did before, we're going to end up, if we plug in our points, so if we plug in 1, or if we plug in 0 into this, we end up getting 1. So it stays here for our secant. So secant's going to be in red. So if we end up saying that we plug in 1, we end up staying at the same point. What if we plug in pi over 4? What would we end up getting? We end up getting, I'm trying to think, 1 over secant of pi over 4. Can't think of it off the top of my head. Okay, so if we're thinking about pi over 4, we're thinking about a 45-degree triangle. So we end up talking about 1, 1. Here's our 45, our 90. 1, 1, square root of 2. So if we end up talking about secant of pi over 4, we end up measuring off, so it's 1 over cosine. What's cosine? Our adjacent over our hypotenuse. So it ends up being square root of 2 over 2. For our cosine, that's where our cosine of pi over 4 will be. So if we end up talking about our secant, we're doing 1 over this. So it's going to be the exact opposite. So it's going to be 2 square root of 2, right? So we end up having square root of 2 because the 2's cancel. So if we end up having this square root of 2, is that more or less than 1? So we know 1 over 1, if we think about the square root of 2, it's going to be a little bit more than 1. And if we think about plugging in our negative pi over 4, we end up having something a little bit more than 1 also. So we can kind of see the trend of how it's starting to go up. And this is also starting to go up. So instead of, like the cosine, instead of following it down, we end up seeing that it does the inverse and it starts to go up. So we can, yet again, just as we did before, we can start to mirror the image. So we can start at our points. And just as we did here, we start to go up. And then from here, instead of coming back down this way, we end up going down. So hopefully this wasn't too confusing for everybody. I know it got kind of long-winded, but I know everyone's going to struggle with this stuff, so we're going to be around to help. This isn't going to be the first time you're going to see this. We're going to be dealing with this all chapters, so just make sure you're staying on task, focused, and doing the homework, because that's going to be the biggest emphasis on everything. So have a good day.